so is worldwide.
So let's start with the first point. We already know that the enormous heating of magma expands the volume and exerts more pressure on the thin crust of the planet. This leads to the expansion of the planet and fractures in the Earth's crust, beginning first at its thinnest parts, which is along the boundaries of lithospheric plates and the ocean floor. In this example, we see the theory turning into reality because the number of earthquakes in the ocean floor has increased significantly since 1995. You can see this now on the graph.
So the Earth starts expanding from within like a balloon. That's the best way I see, and I'm trying to explain that also to the viewers. So because of this, it literally begins to crack at the seams. These seams are usually in the ocean, though, and it's on the seams that the earthquakes increase.
Yep, that is correct. And Professor Arthur Vitorino of Maryland Institute was the first to identify the increase in the number of earthquakes on the ocean floor since 1995. Let us now listen to his commentary.
What intrigued me most was the fact that the number of earthquakes was starting to increase rapidly on the ocean floors. And I said, gee, this looks kind of interesting because it sort of coincides with a large jump in temperature that we saw in 1995. And at that point, I started to research what I call the mid-ocean seismic activity. And sure enough, it's correlated very, very well with global temperatures.
Thank you, Professor Vitorino. Note that the number of earthquakes and their magnitude have started to increase on continent as well. Take a look at this graph. You can see an